All right, guys, here we go. This is the last video specifically from our Algebra 1 textbook. So anything we do after this is going to be talking about Algebra 2 and some geometry stuff. So at the beginning of this year, I told you that we were going to focus specifically on these top kind of 4 functions. This is like the function families we were going to stay in this year. So what we're going to do in this lesson today, and we'll touch on absolute value a little bit, but not as much as the other 3, but we're going to focus on comparing these in a few different ways. Okay, so to help you keep your notes organized, what I would like for you to do at the top is just to create headings for each one of these 4. And then along the left side of our margin, we'll create like a section because we're going to compare a handful of different qualities about each of these. All right, so because this is a review, I'm going to go pretty quickly through each of these. So the first one, graphs and shapes. So remember, linear is going to be a straight line. Absolute value, we remember that the V reminds us it's going to be a V shape, and it could be opening up or down, but it is a V shape with this point on the end called the vertex. Exponential is either something that grows really quickly or gets small really quickly, like there's 2 different options there. When you have exponential graphs, remember you have this line right here called an asymptote. And then quadratics are parabolas, which are like a U shape that are also symmetrical, just very similar to the absolute value. And quadratics also have this vertex point. All right, so that's what you need to know about the graphs of each of these 4. All right, while we're still looking at the graphs, I do want to talk about domain and range. So for linear, and this is just basic ones, this is not ones that have to do with word problems or anything else, but in general, domain and range on linear, notice that linear has arrows going both directions, up and down, left and right. So domain and range are both going to be all real numbers because it's going to extend forever in every direction. For absolute value, domain, again, is going to be all real numbers. So one thing you should know about all of these, domain is all real numbers. There's only one function you're going to learn about in Algebra 2 where that's not really the case. Range on absolute value, this one is just going to go up forever or down forever. So range a lot of times is going to look like y is greater than or equal to some value. And this value right here is going to come from the vertex. Very similar on exponential. Range is going to be y is greater than. Remember, this time it's greater than because there's this asymptote line. So this greater than number is the asymptote number. And then the last one, parabola is very similar to absolute value. Y is going to be greater than or equal to, again, this vertex number. All right, so the next thing we're going to talk about is equations. So if you just want to make like another kind of section in your notes right underneath where this domain and range is. All right, so when we talk about equations, we learned a few different equations for each of these. All right, so there's a few basic ones for linear. Remember, linear equations don't have any exponents. They don't have an x on the bottom. They just have like x and y, and neither of them are being multiplied by one another. And there's 3 different types, right? We've got slope-intercept form, y equals mx plus b. You all should know by now m is the slope, b is the y-intercept. This is called standard form here in the middle. And that standard form here, I'll zoom in so we can see that a little bit better. That standard form is a lot of times when we have 2 rates, that would be an important thing to write down, and a total. So a and b would both be rates and c would be a total. And then we have point slope form down here, which is really good for writing equations. Remember, m is still the slope, and then x and y, x1 and y1 here are an ordered pair that are on the line, a point on the line. All right, absolute value is really simple. There's only one type of absolute value function or equation that we're going to see. All right, and here it is. It's got the absolute value bars in it, which is what reminds you that you're doing a V shape. And this right here is just the same as the dance moves. If you want to write like a note to yourself that this is based off of the dance moves, but remember, inside's the opposite, outside's the same. So H and K are the vertex, and then A out here has to do with your slope. It's what tells you how to change that pattern moving forward from the vertex. All right, so there's you some notes to add about absolute value if you didn't write those down already. So let's look at exponential. All right, so exponential, we've done these before also obviously we've done all of these. So exponential is going to be our growth and decay ones. Remember, A out here is the starting value. I didn't write that down, but you probably should. 1 plus or minus, we do plus if it's growth, minus if it's decay. R, remember that we write R, the percent as a decimal, so we move it twice. And then we recognize these as exponential because X up here is an exponent value. So where X, like in these other ones, X is just a regular variable, in exponential, X is going to be the exponent itself. All right, and then quadratic here is at the end. We've been talking about this most recently, but the biggest thing that you should recognize with quadratic is that we have x squared. Remember, so this first one is standard form. You all recognize that. C is the y-intercept. You know that. I would label that as standard form in your notes for yourself. All right, then we have vertex form. This should look super similar to what we just wrote for absolute value. The difference is we've got parentheses squared instead of just the bars. And so this is x squared because it's got an x with a squared like applying to it. And then we have factored form down here at the bottom, which you all recognize. And this again is x squared because you're going to end up, right, parentheses mean to multiply, so you would end up with x times x, which would be x squared. So that's how we are going to recognize all the different formulas for these. All right, the next thing we're going to compare is tables and patterns. So linear has a constant rate of change. We also think about that as being addition or subtraction. Another word, I didn't write this down, but you should, is arithmetic. Remember that arithmetic and linear go together. And this is just an example of something that's linear. Notice in this table, if you look at the rate of change on this right-hand side, this is adding 3 every time. So that's going to be an example of something that's linear. All right, so absolute value, very similar to linear, because if you think of an absolute value, it's straight on both sides. So I'm categorizing this as a constant rate of change, but with a turning point. So notice in this little table of values here, notice that you're adding 3 here in the beginning, and then it turns around and you're subtracting 3. So it's symmetrical, but you've got this turning point here in the middle where on one side you're adding, on the other side you're subtracting. So that's how you can recognize absolute value. All right, exponential. One of the words that we had for that one, so like with linear, we have arithmetic. With exponential, we have geometric. These are all going to be patterns of multiplication and division, which is why it gets large really quickly or gets small really quickly, unlike linear, which linear is kind of a more steady pattern, constant rate, right? So notice on this one, this is an example of one that is dividing or it's getting smaller. So we're not subtracting the same thing every time we're dividing. So I just want to remind you, you can write divide by 2, but it's better here if you will recognize that this should be multiply by 1/2. That's the better way to write this pattern of divide by 2 here. All right, so quadratic, again, very similar to absolute value. Hopefully in your mind you kind of tie these two together because they do a lot of things very similarly. Also has a vertex or a turning point. The pattern on quadratics, you all know, is 1, 3, 5, 7 over 1. I would write that as a fraction if I could type that way, so you might want to do that for yourself, or some multiple of that. So I've given us just a basic example here. Notice this vertex turning point here is 2, 6. It's where, because on either side we've mirrored that, right? So no matter which way we go, this is +1, +3, +5, and so we can assume that the next one would be +7, and then just like it's going to go the same backwards so that you end up with something that's symmetrical. All right, and the last thing we have to do is just talk about word problems. Remember, what are some of our keywords that help us know which function we're trying to use? So for linear, remember your keywords for rate, per, for each, for every. There's a few others, but those are kind of the main ones. If you have one constant rate of change, so you're looking for constant rate of change, right? You're adding or subtracting the same thing every time. A constant rate of change is going to give you mx, like y equals mx plus b. If you have 2 rates, you're going to put it in standard form. So like a is one of the rates and b is another rate. We haven't spent a ton about absolute value word problems this year, but you will see them at some point, so I just want to go ahead and point some out to you. Absolute value tend to be error-related problems, give or take. A lot of times they're like manufacturing-related. So just this is a little example for you to put for yourself. The ruler needs to be 12 inches long, give or take 0.1 inches. So like if it's 11.9 or 12.1, that's considered okay. That's an idea of absolute value because you're adding or subtracting just the same amount in either direction. Again, we haven't talked about that this year and we aren't going to see those a ton, but I just wanted you to have that for your notes just for the sake of comparison. All right, exponential word problems are super easy to spot. They contain percentages, and they're commonly related to interest or investments. A lot of times they have to do with money. We've actually already done a whole section on comparing linear versus exponential, so that should be pretty easy for you. And we've also talked about quadratic word problems, so we're just tying this all together. So let's go ahead and get our quadratic word problem notes as well. So quadratic, we've just talked about this. You all already know this, but again, it's just a place for you to have this all in your notes, especially if you're going to refer back to them later. So negative 16, remember that's the constant for velocity, or sorry, the constant acceleration of gravity. Most quadratic problems are going to be talking about throwing or dropping objects. It's just going to be talking about how they move. V is the initial velocity, you already know that. S is the starting height, you know that too. H is the height. Remember, I wrote Y equals up here, but you all wrote H equals before. So that's really all you need to know comparing all those. I know that's like a ton of stuff all at once, but really it's just a kind of a big review for you. And what we'll be doing in class tomorrow is looking at a few different scenarios and just trying to decide which family they belong to and making sure you all can go back and forth between. All right.